Hi guys, so in this video I've designed a little flowchart to summarize topic 1 of Unit 3, which is looking at linear regression analysis. In layman's terms, it's looking at the relationship between two objects or two variables. Now, the idea here is we want to find out mathematically how strong the relationship between the two variables is. So this type of analysis is dealing with bivariate data. Bi meaning two, variate referring to variable. And there's two variables that we look at. There's the explanatory variable, which is our x, and the response variable, which is our y. So our explanatory variable is the thing that changes or affects the response variable. Let's see. Now, there's two primary ways of displaying this sorts of information. The first one is a two-way table. Now, a two-way table is great if you have data that is not numerical. Okay, so it's worded, it's categorical data. However, if you do have numerical data, you're going to be using a scatter plot, and the scatter plot is really what we want to use for linear regression analysis. So we're just going to ignore the two-way table for now. Once you have a scatter plot, you're able to easily identify it and describe it in three different ways. You can describe the scatter plot based on its direction. So if it's moving upwards, we say that it is an increasing trend. If it is going downwards, that's a decreasing trend. We can describe it based on its form. Now, a form's referring to whether or not it is linear or non-linear. Linear, the line or the dots, are going to form approximately a straight line. And non-linear, we're going to have a pattern with our data. There's going to be some sort of curve. And lastly, strength. Now remember, strength is what we're trying to primarily do with linear regression analysis. We want to describe how strongly related two things are. So strength, we're going to be talking about that a little bit more. If in a scatter plot the variables are strongly associated, usually those dots are going to form approximately a straight line. If it is weak, or there's no association, those dots are going to be very scattered about and not forming a straight line. Okay, so looking at the scatter plot, you can determine strength, but we're in maths and we want to be able to prove things with numbers. So what we tend to do is use a least squares regression line. Sometimes this is called a line of best fit. Now, a line of best fit, or least squares regression line, is going to form a line through the center of all our data points. It's a straight line, so it has the formula y equals bx plus a. And what do these variables mean? Well, the y comes from your response variable, whatever that may be in the question. X comes from the explanatory variable, again, whatever that may be from the question. B is your gradient or slope. This is the amount the line is going up or down by as you move from left to right. And lastly, A, your y-intercept, where the line is crossing over the y-axis. So once you have this line of best fit, this regression line, you're able to do two more steps. You're able to find what's called the Pearson's correlation coefficient. Coefficient referring to number and correlation referring to relationship. So it's the number that describes the strength of the relationship. Now this is denoted as the R value, and they range from +1 to -1. Ones are the strongest. 0 in the middle there is the weakest of the associations. Now in your textbook you have a really good summary sort of table of these values, and it refers to how strong the variables are associated based on that range. Just remember that a positive value means that the direction or slope is going up and negative is going down. So 0 weak, 1's strong. Once you have your R value, you're able to do something else called the coefficient of determination. This is the R² value, and you can get it just by squaring your correlation coefficient, your R value. So coefficient, again, number. Determination, it's referring to how much the X variable affects the Y. How much is the Y determined by the X? Again, you just find that by the R, by squaring your R, and you read it as a percentage. So if you got, a 90% R² value, it means that 90% of the effects on Y comes from the X. There's an interpretation that I've popped in here too. This is just sort of like a cut and paste thing that you would generally say at the at the end of a question that's looking or asking you about the R² value. So down here we have the R² as a percentage of the variation in the RV can be explained by the variation in the EV. In layman's terms, the percentage change in Y can be explained by the change in X. So this is really the aim of linear regression analysis, to determine what percent is these two variables related. What strength is that relationship? However, it's important to note that this whole process is under a couple of assumptions that need to be true. If these assumptions are untrue, then the numbers that you get are not a good representation. They're false. They're no good. So these assumptions are that you're dealing with numerical data. Okay, if you're not dealing with numbers, then you're going to be using a two-way table, and you can't do any more than that. Number two, there's no outliers. Outliers are going to screw up the strength, I guess, of your regression line, how accurate your regression line is, and your R and your R² values, they are based off the regression line. So if your regression line is wrong, everything else is going to be wrong too. And lastly, most importantly, has to be linear. If you're dealing with non-linear data, you're not going to have a very accurate regression line. Remember that the regression line has to kind of go through the middle of all the data. So the data also needs to be reflecting sort of a linear line or a linear association. So how do you check that it is linear? Well, step one, look at it, see if it's going to be linear. But then after that, and you want to prove it again with some maths, you're going to use some residual plots. So a residual plot is like a secondary scatter plot that you make afterwards. A residual plot will be linear. Will tell you if your variables are linear if the residual plot is roughly scattered above and below I think it's a 0 mark. Definitely need to check out the images of this, by the way. How do you get the values, the data points for a residual plot? You use this formula here. Residual value equals your actual value minus your predicted value. Now, what are these? Your actual value comes from the question itself. Okay, so if you have a question and it says, it's oh, screw it, I won't use an example. Actual value comes from the question itself. Predicted value, though, that comes from your equation of your regression line, y equals bx plus a. And the formula is ideally looking at the distance between the data point on the scatter plot and how far away your line of best fit, your regression line, is. Okay, now I hope this has helped to sort of visualize and connect all of the concepts in topic 1. Note that I have not put in correlation and causation here because a lot of the time that is just common sense. This video is really just a supplementary to your textbook, and there was a really great Unit 1 summary on linear regression. So please check that out first. It's going to give you a little bit more detail, and it's also going to give you visuals, which really help with this. Hopefully this has been of some use to you guys. Please email, come see me in class, whatever, if you have any questions. Thanks, guys.